So we're adding these two functions, okay? So that means what is 2x and a negative 3x? Negative 1x. What is 5 and negative 2? All right, so this is the answer to f of x plus g of x. And you have to ask yourself again, because I'm asking you to also find the domain of this answer. All right, nothing was eliminated with the individual functions, correct? So in this answer, do I have a denominator? Do I have a square root? So I'm still not eliminating any values of x. So my domain is going to be x is an element of the reals.
So like, we don't even need to find it.
No, we're just simplifying, and then we're figuring out, are there any values that x cannot be? We had everything possible in the individual ones, and when we added them, we still had values. All the values were possible because we didn't have a square root and we didn't have a denominator. Okay, Pooja? So the answer is two parts. One is to add the two functions together, which gives me negative x plus 3, and one is to find the domain, which is x as an element of the reals. It's a little C with a line through it. It means element. All right, what am I doing with my two functions now? Which one goes first? So negative 3x minus 2 minus 2x plus 5. But what do I need to do with that negative sign? Pull it through. So negative 3x minus 2 minus 2x minus 5. So when I combine these, I get negative 5x minus 7. So that is the combination of g of x minus f of x, but we still have to ask what the domain is. So you ask yourself two questions. What is is there a, and the answer is there a square root? And the answer is, so I still have that x is an element of the reals. Yeah, it doesn't matter. It's just a C with a little line through it. Uh-huh. If there's nothing that x can't be, that means reals means every number I can think about it. Positives, negative, fractions, decimals. Okay? I'll show you. We're going to get to one in a minute. Okay? All right, this is telling me I want to multiply. I'm multiplying my f function and my g function. Okay? That's just another way to write it. Okay? So that means I'm going to take my f function, which is, so this is saying f of x times g of x, right? And so I'm going to take 2x plus 5 and multiply it by negative 3x minus 2. And so we're going to FOIL. Would you agree? Negative 6x squared minus 4x minus 15x minus 10 gives me a final polynomial of negative 6x squared minus 19x minus 10. Do I have a square root? Do I have a denominator? What's my domain? X is an element of the reals. Huh? Do I have a square root? Do I? No. I don't care if it's squared. I don't care if it's cubed. I don't care if it's cubic root. I don't want a square root. You're not going to have them that high. Okay?
So it doesn't matter, like, if the square root's on...
Okay? All right. What am I doing with my f function and my g function? Dividing. So what goes on top? So 2x plus 5 over? Okay. So f of x and g of x individually were all reals, correct? Do I have a square root? Do I have a denominator? Okay. What value is never allowed in the denominator? So we need to figure out what x value would make that denominator 0 by setting that denominator equal to 0 and solving for x. So we have to find the value of x that makes the denominator equal to 0. And that value can't be allowed. And so we do that by setting negative 3x minus 2 equal to 0 and solving. That means x is equal to negative 2/3, right? Would you agree? That's what makes my denominator 0. If I were to plug negative 2/3 in, I'd have an undefined answer. Are you following me? So my question now is, for my domain, individually, my f of x and g of x had all values were possible now, correct? But when I created this fraction, what value is no longer allowed? So x can be all real numbers, except, that's what this line means, x cannot equal which one? Negative 2/3. X is an element of the reals. Yeah, I don't know. Okay, just means an element.
Oh, is it the little e?
Yeah, XER. X is an element of the reals.
I mean, like, our okay, so like that tiny little e that comes.
No, that just means scientific notation. Okay, so now I'm going to put g of x over f of x. So that's my answer there, yes? So, where am I concerned? The bottom. How do I figure out what makes x 0 there? Set that part only equal to 0 and solve. So, this is my answer to dividing. What is my domain going to say? Except x cannot equal negative 5 halves, right?
Okay, well, at the beginning, like, up there, we were, like, solving.
Well, because I'm adding or subtracting. But what can I do here? How can I reduce this down? If I could reduce it down, Emily, I would. But there was nothing to reduce.
You reduce it as far as you can.
Are we good? What 0?
Like, if it was 2x minus 8.
Okay, next problem. All right. So you've got to be able to read these. What kind of roots are these? Cubic roots. We're fine. Can't we have negative values under cubic roots? You with me? Negative values are okay. I can take the cubic root of a value.
So you can want any square roots.
That's not a square root. That's a cubic root. Oh, okay. You can. This is saying negative 2 and the cubic root of x squared. This is saying 7 and the cubic root of x squared. You can rewrite it so that you can see your domain. Cubic roots are okay. So what are my domain for f and g? Do I have a denominator? Do I have a square root? So what's my domain? X is an element of the reals for both. Do you see how if you ask yourself those questions, they'll help you decide what your domain is? Those are the only two questions you have to ask. Okay, so I'm going to do what with these? So negative 2x to the 2/3 plus 7x to the 2/3 is what? Right, we just did a whole section on how to add these, right? Do I have a square root? Do I have a denominator? What's my domain? X is an element of the reals. What am I doing with my next two? Which one goes first? Negative 2x to the minus 7x to the.
When you're doing this, does it matter whether you have it in the 2/3 or the cubic root?
But you might want to try getting used to doing it in fractional exponent form. Negative 9x to the. Okay. Do I have a square root? Do I have a denominator? What's my domain? X is an element of the reals. Okay, good. What am I doing with these two functions? Multiplying them. Negative 2x to the 2/3 times 7x to the 2/3. This is why we spent so much time on section 2. Am I foiling in this problem? I'm just pushing these answers together. Would you agree? So what is my coefficient going to be? Meg? Negative 14. What happens with the x to the 2/3 and the x to the 2/3? So I have an x to the 2/3 and an x to the 2/3. And my answer, I add what? So that's negative 14x to the 4/3. Right? Well, because 2/3 plus 2/3 is 4/3. Okay. So, do I have a square root? Do I have a denominator? What's my domain? Reals. Okay. What am I doing with this next one? What goes up top? Okay. What do I have on the bottom? Okay. Anytime you create a fraction, before you simplify, you have to ask yourself the two questions. Do I have a denominator? Yes, I do now. Even though I can simplify it out, I put something in the denominator at some point. So how do I figure out what can't exist in the denominator? So I'm going to set 7x to the 2/3 equal to 0. That means x to the 2/3 is going to equal to 0. What is x going to equal? 0. That's the value that x can't be. So when you create a fraction at that point, you ask yourself the two questions. Okay? All right, now let's simplify. An x to the 2/3 over an x to the 2/3, what happens to my x's? They cancel. So this simplifies down to simply negative 2/7, right? Would you agree? So it looks like 0 should work. But because of the fact that when I first did my substitution and I created that denominator, I need to say that x is an element of the reals, but x cannot equal 0. Does that make sense?
Well, I don't get the second part you said where you're like, it looks like it should be 0. No, where I just where I said like it should be 0, yeah, the answer's 2/7.
Then I said something wrong if I said that. I'm sorry. It looks like the answer should be negative 2/7 with no variables in the denominator, but we created having a variable in the denominator, so we have to let us know that.
So is every answer going to be x is an element of the reals
Yes.
with something else?
Yes. Maybe. Exactly. All right. Composition. I want you to know that composition is just substitution, because you guys are going to make this so hard, and it's not. It's not. Composition is substitution. What looks like composition is this right here. This is an example of a composition. And you work from the inside out. Okay? So f of x is 4x to the negative 1. And g of x is 5x minus 1. What's the domain of this? Mm-mm.
It's in the denominator, so it's all real numbers except.
So for f of x, x is an element of the reals, right? But what can't x equal? Yep, x can't equal 0. Because it's negative exponent. Make that exponent positive. That means it drops down, right? So it's 4 over x. X to the negative 1 drops down to the denominator and becomes a positive exponent. X to the negative 1 is 1 over x to the positive 1. And then we set this part equal to 0, and that's what x can't be. How do,
Just do it in your head right there.
well, Emily, how do you make any negative exponent positive?
Bring it to the denominator.
So if I have a 4x to the negative 1, the x is the one with the negative exponent, so the 4 stays up top, and the x goes down below.
Okay. Then you said x.
And then this is what our issue is, so that's what we set equal to 0. Better? No square roots, no denominators. X for this one is an element of the reals. You with me? You really got to pay attention to this stuff, guys. Okay? All right. This is saying you're going to work from the inside out. So we're going to figure out what g of 5 is. That means I want x to equal 5, and I want to substitute into g of x.
We have a question. Do you need to find the domains of those things before you can do that?
Yes. Yeah. Okay, so g at 5 means 5 times 5 minus 1. Would you agree? Well, g of 5, there's my g function. And g of 5 means letting x be 5. What do I get? It's just substitution. So that's 25 minus 1, which is, so what is g of 5? Go back to this. So now we want to do f of what? Nope. 24. Because we figured out what g of 5 was, right? Remember I said work from the inside out. We figured out what g of 5 was. It's 24. Now we take that value and plug it into my, so I want f of 24, which is going to be 4 over 24, which is 1/6. Okay, negative exponents drop down and become positive. Because f of x is 1 over, or 4 over x. Yeah, absolutely. Yeah, that's okay. 0.
So whenever you see like
F of 24 is 1/6. What, can't x ever equal? No, x can't equal 0.
so the answer would be all reals.
Well, I don't have to know about my domain right now. Okay.
So whenever you see like a parentheses and then like inside a parentheses, it means like the g of that number.
So find g of that number, take that answer, plug it into your f function. You're just working from the inside out, doing a substitution. So where in this problem does my 5 go? In the f. So I'm going to do f of 5, which is 4 over x, which is 4 over 5. So what is f of 5? 4/5. What do I do with that 4/5? So now I want g of 4/5, which is 5 times 4/5 minus 1, which is 4 minus 1, which is 3. What's the final answer? 3. Because now I'm done substituting. It's a 2-step substitution process. You getting this? That's the final answer to that problem. That's what f of g of 5 is, 1, 6. We found g of 5. We took that answer, put it into your f function, got an answer of 1, 6. Because that's what I wanted to do. I wanted to find g of 5, take that answer, and put it into my f function. So remember, you're working from the inside out. Okay, now, notice that this has no variables. I mean, no numbers. So I'm not getting a numerical value. I'm going to get a polynomial or some kind of an expression with variables. Now, I want its domain. So, what did we say f of x's domain was? Couldn't equal 0, right? What did we say g of x's domain was? All real. So currently, because I'm putting them together, we cannot have 0 as one of our answers. You guys are falling asleep, and I'm really sorry. But this is going to be something that you're going to struggle with if you are not with me. All right? I want f of, what's my g of x? 5x minus 1.
Wait, why are you doing that?
What's g of x?
That's confusing.
No, well, because look, I had 5 and I put it in my f function. And I took that function's answer and put it in my g. Now I no longer have a value. So g of x is also known as 5x minus 1, right? So now, what is f of x? F of x is 4 over x. Where is that 5x minus 1 going? So it's 4 over 5x minus 1. This value is going down here. Because that's where my x was. My f function had the x down here, right? So whatever I'm wanting x to be, which in this case is 5x minus 1, that's where it has to go, where my x is. Remember, it's a substitution. Okay, what can't x equal? And y. Why is it 1/5? You're going to have to look at this denominator. 5x minus 1 can't equal 0, which means 5x can't equal 1, and x can't equal 1/5. So x can't equal 0 because we were dealing with 4 over x. And now it also can't equal what? 1/5. So x is an element of the reals, but x cannot equal two values now, both 0 and 1/5. No, it's just part of it. What do you mean, Pooja? Okay, our previous one had values for x. I don't have a value for x. This has no x in it. I mean, this has no value, no numerical value. This is only working with your polynomials and substituting them in. Your final answer is this. Well, if there had a number, I would have plugged it into my g function, taken that answer, plugged it into my f function. 10 minutes. Thank you. All right. This is substitution, guys. This is all this is. It's substitution. It seems harder because you're doing polynomials, but this is substitution. So then let's do g of f of x. Let's flip it. So working from the inside, what are we substituting into our g function? Which is what? So it's 4 over x is what's got to go into my g function.
And so then g's x will go into the 4?
No.
G's x will
You're just replacing whatever is x. So my g of x is what? Minus 1. So what's going to go into this spot right there? 4 over x. Does that make sense? So that means what I really want to have is 5 times what? 4 over x minus 1. Which is what? 20 over x minus 1. Do you see how this is just a substitution problem? Is there a denominator in this problem? So what can't x equal? X is an element of the reals. X cannot equal 0. Hasn't changed. Bless you. Yep. And the book will probably, well, I'll just take that. That's fine. It might also say, well, that's 20 minus x all over x if they decide to get a common denominator. All right, find f of x. What is f of x? All right, so so I want f of 4 over x, correct? I'm putting the function into itself. So that means I want, where is this going to go? As the x in f of 4 over x, right? So it's going to be 4 over x, which is 4 divided by 4 over x, right? Right? What do I do? So that's 4 times x over 4. Multiply by the reciprocal, right? If you're dividing, you got to flip and multiply by its reciprocal. This is 4 over 1. What is this final answer? All right, but what can't x equal? Why can't it equal 0? Because it couldn't equal 0 in the original problem, and it never changed throughout this. Meg? The final answer is x. So, this is what I'm substituting into my f function, right? This value, if this is my f function, has to go right there where that x is, which is this. This is saying 4 over 4 over x. This is 4 divided by 4 over x. If you take and divide by a fraction, you multiply by the reciprocal. I mean, what's 1/3 times 2/5, or divided by 2/5? Isn't it 1/3 times 5/2? What is 4 divided by 4 over x? It's 4 times the reciprocal of x over 4. So these 4's cancel out, and you're left with x. Katie. Oh, sorry, Ellen. Mm-hmm. It's still going to tell me that it's going to be equal to 0. If I set 4 over x equal to 0, I'm still going to really know that x can't equal 0, because it's going to, if I plug in 0 here, it's still going to give me an undefined value, right? Does that make sense? Okay, let's try g of x. What is g of x? 5x minus 1. Okay, that means I want g of 5x minus 1, right? If I'm plugging, that's what g of x is, correct? So where is my x? Right here, correct? What am I going to put in there? So I'm going to take that 5 that's sitting out here, and I'm not going to lose it, right? And then I'm going to put, instead of x, what am I going to put? And then what am I going to still have to add on? Minus 1. Yes, there is. And then I get 25x minus 5 minus 1, which is 25x minus 6. What was the domain of g of x? Did I ever change that in the course of this problem by creating a denominator or a square root? So what is my domain going to be? Are we on overload? Hard chapter.